Hello. 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 Am I audible?
Yes, ma'am.
Okay. So let's start. So we will start today filtration. Uh, Let me share my slide. Can you see the presentation?
Yes, ma'am.
Okay. So filtration after sedimentation, basically coagulation and sedimentation. The third unit process in water treatment is filtration. The aim of this particular treatment process is to remove not only the flocks or colloidal particle, but also to like you can say a major extent bacteria can also be removed in this process. As its name suggests, filtration means we are filtering the water through some medium, or passing the water through some medium. So clear water will come out and impurities will remain in that medium. So there are three type of filters. First two type, which is slow sand filter and rapid sand filters, are gravity filter, because they work on the principle of gravity. No additional or external force is applied to percolate the water through the sand or gravel media. Okay. So the third type of filter is pressure filter, where we apply the external force or external pressure to increase the percolation rate or filtration rate through the filtration medium. Now, in after knowing this, we need to understand what are the mechanism that is actually happening inside the filter unit, which removes the impurities from the water. So there are different process we can imagine being carried out inside the filter media. First, say mechanical straining. What does it mean, mechanical straining? Say so. What first? Let me just explain. I will share my whiteboard. Okay, so say in general, the filter has such kind of arrangement. It will have the sand layer, okay, a thick sand layer, and then uh, of sometime uniform size, sometime it could be of different size particle. The sand layer could be either very spherical particle, or sometime mixture, but most of the time in reality these sand particles are mixture of non-spherical and spherical particle. Then this is the top layer, and then below this would be the big gravels which will support this sand layer. Okay, so gravels will support the sand layer. Okay, now what happens, uh, one thing that may happen is, like on this top sand layer, the impurities which are bigger than the size of, let me make the impurities with red, bigger than the size of void. This is the void, right? So bigger than the size of the void will be captured. Okay, after one layer is formed, this whole sand bed will have more fine or more finer voids, and that will cause further removal of small impurities, small size impurities, right? So first layer will form which are the particles greater than the size of the void. Once they are captured in this void, okay, of the voids, the size of the voids will be smaller, and therefore this whole layer will be able to capture more like smaller size particle, right? So this is called the mechanical straining. Okay, so now a smaller size particle can be captured inside these voids. Okay, this is mechanical straining. The second, so this is the first maybe phenomena which is working. The second is the dirty skin. Not second. Second, I have 1 minute. Let me see sedimentation. In sedimentation, okay. Mute your mics. Please mute your mics. Okay. Can you hear me now? Right? Can you see the whiteboard? Can you see the whiteboard?
Yes, ma'am.
Okay. So now again say these are the sand particle. Okay. The second process is sedimentation. Sedimentation. So in this process, we believe that in this sand layer which has voids in between, each void, for example, here say I have the sand layer and which has voids. So this void, uh, let me say this one. This void worked as a sedimentation tank. Okay, small, very tiny sedimentation tank, and therefore the impurities which are very small in size, they when the water percolate through this voids, this impurity get settled down due to gravity, which is like in plain sedimentation type of process. So this is the second process we believe that happens in the filtration unit. The third process is formation of dirty skin. That is also known as biological process. Okay, let me see its name. Yeah, biological action. Okay, so in biological action, what happens? The bacteria which is present in water. See, if this is the sand grain, okay, and bacteria are also present in water. They are getting
Ma'am, the
settled.
whiteboard is stuck.
Why food is?
Stuck. We cannot see after the first mechanism.
How come you are not able to see? Can you see now? Can you see now?
No, ma'am, still we are able to see first point, first mechanism.
Oh, okay.
Actually, it is visible after zooming out.
But I did the zoom out. Now can you see? Can you see now? Can you see? Just tell me, otherwise I will just explain through PPT.
No,
Can,
ma'am.
no, say, no?
Ma'am, it's visual from the start.
No, what is happening?
We have to zoom out.
Okay. So I have zoom out now. Is there a way to zoom out, zoom in? I'm just doing it using my mouse, but maybe there is some way. Add shape, text, no, and zoom. Okay. If you are not able to see it, just let me know. I will switch to presentation. Okay, so can you see now? Can you see now? Astha Jain, Abhishek Kumar, Lalit Meena, can you see now?
Yes, ma'am.
Okay. So see here, these are the sand grain and the bacteria is present in water and they are present in the voids. Now what will happen? This bacteria will consume the organic matter, okay, for their survival. So once they start eating the organic matter and converting this organic matter to harmless compounds, okay, then what happens? And these organic matters are actually algae and plankton, then etc. Okay, so once this harmless compound form inside this voids, it will actually form a layer on the grains. So a layer of harmless compound will form on the grains. This layer is known as dirty skin. Dirty skin. Okay, now this will further actually reduce the pore size of the sand grain and therefore it will increase the filtration, the smaller size of the particles will be captured in the void. So this is another mechanism that may be happening the inside the filtration process. Okay, can you see the PPT now? It should be visible. Yeah, okay. Let's then, so this biological action I have explained. Then the fourth type is electrolytic changes. So what is happening? Probably the impurities will have opposite charge than the sand particle. Because of the opposite charge, the impurities are getting stuck on the sand particle and neutralize the charges. That is another way of, like, you can say, explanation for filtration process. And one of this process or all of them might be happening inside the filtration unit. So this is what the filtration theory says. Now as I said, there are two gravity filter are of two types: slow sand filter and rapid sand filter. The slow sand filter, I have given some of the quality or properties of slow sand filter. Basically, the slow sand filter will have very fine size sand particle. Okay, therefore the voids between the sand particle will be very small, and the filtration or percolation rate will be lower than the rapid sand filter. Rapid sand filter will have larger size of sand grain. Okay, so this is the basic difference. The arrangement of the layer of sand and gravel is same in both the filter, only the difference is in grain sand grain size. Okay, so one of the parameter that which indicates the grain size or the sand size is effective size. Effective size D10 is for slow sand filter is between 0.2 to 0.4 millimeter, means the sand grains of size 0.2 to 0.4 millimeter are 10% of the total weight of the sand. Okay, whatever, say if I am using 1 kg of sand in that filter, then 10% of 1 kg is of size 0.2 to 0.4 millimeter, which is passed through like means of a particular sieve. So sieve analysis, maybe the students from civil engineering have learned about the sieve analysis. Sieves are like, you have also seen the sieve in your home. So these sieves are arranged in such a way that the top sieve is of a bigger size, and then smaller, and the bottom sieve will be of smallest size. So in order to define the size of the sand particle, D10 is the effective size of the sieve in millimeter through which 10% of the sand, minimum 10% of the sand will pass. Okay, 10% of total mass will pass. Then uniformity coefficient, that means uh, the size of the sieve through which 60% of the medium will pass, divided by the size of the sieve through which 10% of the medium will pass. Okay, so for example, say I have a sieve size of 5 millimeter through which and I'm passing 1 kg of sand through the stacked sieve, and like from the 5 millimeter sieve size, where the sieve opening is 5 millimeter, say 60% of the whole mass, means 600 gram of the mass is passed. Okay, then D60 in my case will be 5 millimeter. Then D10, say there are the bottom sieve which is of 2 millimeter in size. Okay, and from that sieve, say 10% of mass, only 10% passed through that, and like 90% remained above that sieve. So that D10 would be 2 millimeter. Therefore, D60 by D10 will be 5 by 2, means 2.5. Okay. So in this way, the uniformity coefficient can be determined, and which define the on an average what would be the size of the sand particle used in a filter. Okay. The depth of the sand could vary between 90 to 110 centimeter. Depth of water over the sand media would be approximately it varies between 1.1 to 1.5 meter. Actually, here it's not given the same as the depth of the sand media. Okay, it is given, it is same as the depth of the sand media. Okay, so say if our sand media has a depth of 1 meter, then 1 meter water will be filled over the sand top of the sand medium. Okay, the design period is 10 years. So the flow sand filter can be designed for 10 years. After that, you have to renew the filter. Okay. So this is the type of arrangement in slow sand filter. The supporting gravel is on the bottom, Then one thick sand layer is on the top. The depth may vary 0.5, 0.6 to 1.2. There it was given 90 centimeter, 0.9 to 1.1 meter. That is okay, which is within this limit what is given here. And then above that there is a water, and the water is about 1 to 1.5 meters. So because of the weight of this water, the percolation of water will happen through this sand media, and then it will come to gravel, and then the clean water can be passed through various pipes, right, on the bottom, which are arranged in the bottom of the tank, and then it can be collected in a reservoir. So this is simple mechanism of filtration. The other cleaning of the slow sand filter. So for cleaning the sand filter, generally what is done, we remove the top 1.5 to 3 centimeter layer of the sand, we wash it, and then again fill the same sand in the filter. So that is one way. Just remove the top 1.5 to 3 centimeter layer of the sand and clean it and again use it. The filter is washed with good water, so clean water is needed to wash the filter. Generally, the back washing or the water required for washing is also considered in designing the water treatment unit. Okay, so whatever is the demand of the water, other than that, uh, like additional water should be available for cleaning purpose in water treatment plant. The frequency of cleaning is 1 to 3 months. Rate of filtration 100 to 200 liter per hour per meter square of filter area. This particular unit is capable of removing the bacteria by 97 to 98%. If already the water is chlorinated, pre-chlorinated means chlorine is used to kill the bacteria, then its efficiency will go up. The filter cannot be used if the turbidity is greater than 50 ppm. Okay, if it's very turbid water, then this process is not that much effective. Okay. Generally smaller size plant, like this type of filter can be used in smaller size plants like in villages and all. So in order to know how much what should be the thickness of the filter media, one parameter we should know is initial head loss. Means the difference in pressure applied on the filter on the sand bed and the pressure through which the water is going out. Okay, the difference between these two pressure or measured pressure is known as the head loss. Okay, so initially the head loss can be calculated using this formula, where v, small v is the filtration velocity or approach velocity through the filter media in meter per second. Capital D is the depth of the filter in meter. Okay, phi is the shape factor for non-spherical particle, sand particle. D is the diameter of the sand particle in meter, and this diameter will vary. Maybe we can have a sand material of uniform size, that is also possible, but in general we do not have uniform size particle. We have like certain fraction of a particular size and then certain fraction of another size and so on. So that is why we do the sieving of the sand material, to know what is the fraction of a particular size of sand particle, okay, in total media. G is acceleration due to gravity, we know, and porosity of the filter media. CD is the Newton's drag coefficient, and F is the mass fraction of the sand particle of diameter D. So this particular formula can be used in order to determine the initial head loss, which should not be more than 0.6 meter. Okay, so the head loss should be as minimum as 0.6 meter. Okay, not more than that for effective functioning of the filter. Then rapid gravity filter, it's a similar process, just the sand grain used in rapid gravity filter is larger in size than the slow sand filter. Therefore, the percolation rate of water through filter media is higher in rapid gravity filter compared to slow sand filter, and this type of filter can be used for larger community where the water demand is very high. In this particular filter, gravity type filter, the backwash unit is also provided. What is the purpose of the backwash unit? This unit will have the clean water, okay, and like portion of the clean water will be stored, and that would be passed from the bottom towards the top of the filter. You can see the blue arrows, right? So once the filter is clogged and the head loss is below the desired limit, or you can say high, head loss is high, then the water, clean water will be passed from the bottom towards the top in order to agitate the sand bed, okay, and then this sand bed will be agitated, and therefore the impurities which are binding around the sand particle will be removed and washed out. This is a general washing process. You are applying the water from the bottom at a pressure, at a certain pressure. Okay, it's not like without pressure. You cannot uh, provide the reverse flow without pressure, right? So this is how it is. Now the number of filtration unit required for a treatment plant can be calculated using a formula N is equal to 1.22 under root Q, where Q is the plant capacity in million per day. So this is simple formula given for this filter. So the same kind of information is given here, where uniformity coefficient D60 by D10 is lower in this case, 1.3 to 1.7. Okay, so that again means that there is a more large size of particles would be there. The operational problem in filtration is first air binding. Air binding is actually what happens, like as I said, with the like the filtration process goes on. As the filtration process goes on, the impurities captured in the void will start by clogging the voids, right? The voids will become smaller in size, right? And after some time there is an increase in head loss, and that head loss will become very high after continuous operation of the filter. And once this head loss is high, there would be a chance of negative pressure, okay, not the positive but negative pressure, which may cause the release of the gases from the water. So in water, there, because it's a impure water, there is a possibility of impurity present in form of gas also, right? So that gas, for example, H2S, maybe some H2S is there inside because it's a soluble in water. So that gas will come out from the water and form a bubble. This bubble will further cause the clogging of the voids, and that process is called air binding. They will just block the or clog the voids in the sand media, and seriously it will affect the working of the filter. So that is one problem that may happen. Therefore, the continuous monitoring of pressure is being done in the filtration unit, and once the pressure drop or the head loss at the inlet or inside the filter, the the water which is percolating through the filter, and the outlet, like from where the clean water is going to the other tank. If the head loss between these 2 points is above a certain limit, then we have to have the backwash or the cleaning of the sand, or whatever the process for cleaning the filter media. Okay. Operational trouble, mud form in the atmosphere. Okay, so this is actually the mud particle or the clay or sand, whatever, if they are present in the atmospheric air, they may also like settle down on the top of the filter media, because it's an open unit, it's not a closed unit. Pressure filter is a closed unit, gravity filters are open unit. Okay, so this mud particle will actually settle down on the top of the filter, and then what happens is this mud particle will stick to the sand grain, and they will form a slowly they will form the mud balls. Okay, this mud ball further sinks inside the filter, they will sink inside the filter, and they will clog even the gravel layer. Okay, sink down in the gravel layer, and they will clog the whole filter, and that can be this interferes with the upward movement of water during, so even the backwashing will be affected if the mud balls form inside the filter. Cracking of filter, see the top layer of the fine sand, because they have a very you can say the muddy layer form around the sand particles. That top layer may shrink sometime because of the you can say dryness, and there would be a crack if the filter is not being used, if water is not there, you have removed the water from the top because you want to clean the filter. That the top layer may shrink and it will have a crack. This crack is widened sometime, this crack will widen, and again by the pressure applied on the filter, and thus the flocks, mud and other impurities may further penetrate deep into the filter, and therefore reducing the efficiency. So this is another problem that may happen in the filter. So we have seen the gravity filter. This is the pressure filter, where the this is a closed unit, and the water is percolated through the filter media using the pressure. So we are applying the pressure, we are forcing the water to percolate through the media, and generally this kind of unit, so percolation rate is very high compared to gravity filter, because we are applying the pressure, and generally this kind of unit is only used for industrial water, because it is not economical for the municipal water supply. So the filtration rate is very high in this filter, 6,000 to 15,000 liter per meter square per hour, and this that this type of filter can only be used for industrial plant and treating the swimming pool water, which is like relatively clean water. If the water has like more blocks or colloidal particle, then this particular treatment unit is not recommended. Okay, so it is good for relatively clean water, so like after softening and all. Okay, so this I think the disadvantage is also written here, you can go through this. So this is about the filtration, and I will actually, I think in this slide there are some formula which are missing. Either what I will do, I will teach you those one or two formula only to calculate the head loss and all. I will teach that in the next class briefly, and I will also include those formula in this presentation. Is there any question? Any question? Can you hear me?
Yes, ma'am.
Okay, is there any question or mechanism or anything which is not clear? So do you get your quiz answer?
Ma'am, for one question there was no answer.
What? One question?
There was no proper answer in the quiz. Actually, there was no correct option for that.
Which question?
That question where they asked for the stable atmosphere condition.
Okay, it's related to buffer, right? What do you say? Can you repeat your?
Ma'am, the question where they asked the lapse rates for stable condition of atmosphere, correct order for moist lapse rate and those all for the stable.
Correct order of moist lapse rate.
Yes, ma'am. For stable atmosphere.
So that question you are saying the answer is not proper.
Means there was no correct option.
No correct option. Okay. So did you select no correct option? Was it given there?
No, ma'am, there was no such option. We kept one of those options. For some of us, it was correct. For some of us, it was wrong since they gave some answer.
Okay, let me then talk to him. Diljit. And okay, is there any other question or any other issue we would like to discuss? So next time we will learn the disinfection process. So one disinfection and water distribution network. Two lectures are remaining in water treatment. Then we will start the wastewater treatment after that. So how many classes are remaining? Do we have 4 to 5 class at least?
Yes, ma'am.
Okay, so we will finish that. Now this is also time for you to have your second assignment, but probably I will. When is your exam?
Ma'am, schedule wasn't released yet. It should be in May, somewhere at May 2nd week.
Second week. Let me see. I have a academic calendar.
It is from May 8 to 16.
Okay, May 8 to 16. So that in first week of May, probably or last week of April, maybe after 25th April or so, I have to give you the second assignment. Okay, fine, fine. And one more. Okay. So your how many marks exam have been done? Like assignment, quiz, one assignment, and one minor one. Okay, fine. Is there any question regarding any other issue related to class? No?
Ma'am, excuse me.
Ma'am,
Yeah.
what was the policy about the quizzes? For example, the best two quizzes will be taken if our attendance is greater than 90%.
Yes.
So,
Other one is the average.
okay. So, as you just now said that we have just limited number of classes, so are we expecting more than two quizzes to happen, because otherwise it won't be
No,
fair.
it's not best two, it's best 1 out of 2.
Best one out of two, yes. You're right.
Okay,
Otherwise,
ma'am.
the average. I'm sorry.
Excuse me, ma'am.
Yes.
Ma'am, actually it was regarding the attendance sheet shared two, 3 days before back. So there were some names which were highlighted red. Why is that so?
I have not seen your attendance list because I asked TA to upload it. I was traveling that time. Or maybe, let me just see. I have that sheet with me. Let me just see if I. It should be on your here also, right? On MST.
Yes, ma'am.
It's in under file. Mm, Attendance combined. Hmm. No, I have to find out. Probably these are the students who have either withdraw or something because their name may not be in the final list. Probably because see, there are red drop happened, and then I will find it out. But this is seems like 0 0 attendance all the time, except in few cases there's one attendance. So maybe they have attended the class before withdrawal and then they withdraw the course, and after that they have not attended any class.
Ma'am,
So
actually, I have attended every class and I'm still enrolled. Ma'am, second name on the
your
top.
name is there. Okay, no. So it would be by mistake. Your name should not be. See the other student, you can see all zero except two classes they have attended, right? So I will
But
ask
some
them
names
right
in these
away.
were repeated up and below. I didn't get that also.
What?
Some of the names in this red were already provided above also.
Where?
Some of the names who were in red were also in the above list again. I didn't get that.
Okay, let me find out then. The TA must have done something and highlighted it. I will find it out. But it seems like these are the people who have, most of them have dropped.
I
Probably.
guess they have attended from their personal ID, I guess.
I don't know. Let me see. But if you have attended from personal ID, then how can I? If it like when I take the attendance list, whatever whoever will attend the class, it will show up. So it's not like whenever you will log in. So if somebody will attend using the personal ID, that means he will appear as a guest, right? Right. If you are attending using your Gmail ID or something, then you will appear as a guest. So I don't know. Let me ask my TA. She will explain. So you have seen your attendance, okay? Right? No problem. Other than this,
Ma'am, hello. Ma'am,
yes.
ma'am, as it was said that we would just count attendance after 12th February, right? Because that was add drop period. I was added late to the teams. I was
So
added on
what I
12th.
told to my TA, start attendance counting after add and drop period only.
But
But I told her also that maybe there are some students who will creep about like, no ma'am, I have attended two class before add and drop. After that I got sick or something, I did not attend. So I told her to just keep it. Whoever will say, ma'am, just I'm short with one class and I have attended it before add and drop, we can include that attendance for that particular student. So you know means there might be some student, they will say, ma'am, I got sick, after that I couldn't do the class. However, I'm getting short with one attendance only. So I'm not rejecting anything for the time being, but basically the major counting is after the add and drop only. This is what I instructed to my TA. Let me find out what she has done. Is that okay?
yes,
Right?
ma'am. Actually, they have taken it into account and given percentages after considering those attendance as well.
Okay. Let me talk to her. If she has done it for everywhere, everybody, then I will remind her about this policy. Okay, so next time we will start the disinfection. Uh, that means the process that actually kills the bacteria in water, and disinfection is a necessary unit process before supplying the water for drinking purpose. And there are many disinfectant which are being used. The most common is chlorine, then ozone, then UV radiation is also used sometime for killing the bacteria, and that we will see in the next class. Okay, thank you for attending the class. Bye. Let me see if I have downloaded the attendance or not. 76 attendance. Yeah, it's there.